Based on the literature findings, there are no semiconductor domain-specific ontologies. Considering that the domain knowledge is already existing in the data models, databases and other formats, we want to make use of this and create automatically ontologies out of them. This demonstrator shows a routine of how an automatic update of the digital reference ontology with the generic data model domain knowledge is performed. Based on the generic data model structure, an ontology is created by running a Python script every time there is an update in the generic model. More specifically, it is to have an automation mapping script that can translate XML and SQL into RDF and OWL formats. We propose a set of rules for how OWL ontologies may be generated automatically from existing XSD schemas. A generic data model was developed by Bosch during the Productive 4.0 project and improved during the Support Action SC to the Power of 3 project. Improvements to serve the purpose of running simulations, real-time dispatch and capacity planning in semiconductor manufacturing. These improvements together with the already existing semiconductor domain knowledge of the generic data model is transferred into the digital reference by creating an ontology out of the generic data model. We can see in this diagram that we have the model with different master entities, such as infrastructure, process, product, trace, strategy and snapshot. Each of these master entities has its corresponding classes and attributes. Developed as a UML format, the model can be exported in other forms, such as XML and SQL data. In this demonstrator, we first export the model into an XSD format. Then we select all the master entities we would like to export and then we give name to these files. Once finished, we click on Generate and we have all our XSD files available. We can open one XSD and visualize it. In this example, we open the infrastructure master entity. When taking a closer look, we can identify some features that can be used to map the data structure into an ontology. We can recognize that all the terms represented as complex type are classes and all the terms represented as elements are data properties that belongs to that class. Also, the attribute type that is inside of the elements represents the data type property in some cases. In other cases, they define the relationship between the classes as object properties. In this example, we use the term has to describe the property. For example, a fab has an equipment group or an equipment group has an equipment. Translating these rules into an algorithm, we can write a Python script that can map these features with their vocabulary into an ontology. The graph creation based on the XSD input data is done using the Python redflib library using the earlier rules. The vocabulary provided by the XSD schema is then assigned with the redflib methods into ontology classes, data properties and object properties using the standard and custom URIs. After creating the ontology graph, the output file can be serialized into different formats such as RDF, OWL or TTL. Also, few methods are developed to feed the instances into the model once the graph is available. The newly created ontology can be visualized in the SC to the Power of 3 project platform. Therefore, we go on the SC3 portal website and we use the web protege to check the content of the GDM ontology. Once it is loaded, we have the option to create a new project where we upload our newly created TTL file. Here, we can see the master entities defined as classes and their corresponding subclasses. Under properties, we have all the classes relationships defined as object properties. Data properties are assigned to its specific class and to the corresponding data type property. A second way to check the newly created ontology is to visualize it with the VAL platform. We go under Projects and we upload once again our file there and we click on it. Under Hybrid mode we can check all the resources and their relations. We also have the possibility to check it graphically. Now the generic semiconductor data model is ready to be imported or transferred into the digital reference. There are ongoing activities that this model is mapped into the digital reference. Additionally, anytime where there are updates in the generic model, these are transferred into the platform and blockchain technology is used to decide whether these changes will be transferred or not.